Okay, so I'm going to share screen. Okay. So first is what is concept of join? Okay. So like we know there in SQL join is there, right? SQL joins are there, right? So join is basically a process of combining the data of two data sets. So it's combining the data based on the columns, right? We are joining the columns. Okay, we are joining the columns in the data set. Okay, so if I say like I have a in SQL like normal Oracle or DB2 or SQL Server or any database, so we have like two tables. If I example employee table is there, employee ID, employee name, okay, employee department, okay, so EMP department, DPT ID, and separate I have a one department table. So that department table has a department ID, same column will be there, whatever column is there in the, because this is the foreign key and this is the primary key. So this department ID is foreign key, this is a foreign key here, because this employee ID is primary key, okay, in this employee table. In department table, we have two keys, department ID, department name, okay. And here I say this department ID is primary key for this table, okay. So this is the tables, okay. So here is join is there between the employee and department by using the department ID, okay. So if I say I want to write an inner join, the inner join is basically bringing the common data. So suppose I'm just taking some example, employee ID 1, employee name some test, and department is 101, okay. Employee 2, test 1, and 102 department, and employee ID 3, and this employee is in the same department 101, okay. So now here I say the two department I have, 101 is admin and 102 is HR, okay. So just I'm taking example. So when I want to join, so how the data should come? So I say 1 2 3, three employees, and their name I want to display test, okay, and then I want to display the department name. So 101 admin will come. For 2, it will be test 1, and then department is 102 HR. And for 3, it's a test 3 is the name, and the department is admin. So I need this data because this inner join will be giving us this data. So in SQL, how to do the join between these two tables? So select from employee E, some alias, and inner join I'm using department dptd on E dot dptid equal to D dot dptid. Okay. So this is a join condition. And what are the column I have to fetch? E dot employee ID, because employee ID is in only in employee table. E dot employee name, EMP name, that is also there in the employee table. But D dot name is D dot, okay. So D dot I will be giving department name, D dot department name, D dot department. So this is simple join query, okay. So I want to do this kind of join. There are the other joins also there, left join, right join, and self join, cross join, and full outer join, okay. So these many different types of joins are there. I will tell in Hive all other joins. Just I'm taking example, like if this kind of situation, if this same data is there and you are using a MapReduce, so how to do the join? So MapReduce is providing the two types of join, okay. MapReduce is providing two types of join, one is map side join and reduce side join, okay. We know two component are there in MapReduce. So what are the two component? Map and reduce, okay. So what map side join says, when the join is happening at mapper end, when join is happening at mapper side, that join is called map side join, okay. So here the output will be your mapper output. So when map side join is there, it means there is no reducer. So here is no reducer. Only output data is coming from mapper directly. So how many phases will be there? First will be map phase, then it will be shuffle and sort, and then output. Then directly will come output. Okay. But in case of reduce side join, it is saying when join is happening, when joining happening at reducer side. Okay. That join is called reduce side join. And here, this is a normal join, we have seen the all output are coming mostly are the reducer output file. Okay. So here is output file will be mapper output file, right? So my output file name will be part m-0000. So like this, my output file will be there. But in this scenario, we have already seen the simple programs, right? Like we have seen partitioner, combiner, and simple word count. So we have reducer. So whenever reducer is there, so output file name will be part r-000. But in case reducer generally like maybe one file, two file, depending on the partitioner. If partitioner is there, then number of output file will be more. If partitioner is not there, if it is using hash partitioner, so only one output file. Okay. So that is the difference between the map side join and reduce side join. Okay. So what is the need of map side join and reduce side join? So one distinction is there. Map side join, if two data sets are there, so one data set is very small, and one is very, very large. Okay. So if I'm saying the example of employee and department, so in any company, the department data set will be very less and employee data set will be very, very large. Okay. So this kind of data set, this kind of join is always map side join. Okay. So map side join, one small data and one large data set, like example, employee data set is large and department hardly 5, 10, 15, 20, and most to most like 50, 60 department. That is too large department. Okay. If it is very, very big organization, but mostly department like 5, 10, 15 departments are at max, and the employee data set will be very large. Okay. So if I say employee data set is very large and department data set is less, very, very small. Okay. So here one concept is there, distributed cache. So distributed cache is this small data set, which can fit into memory. We can use one directory in Hadoop file system in SDFS and store this file. So this file will be permanent, right? Because department will never change. Department will not change. So I will keep it in a distributed cache, one directory, and I will keep it this file in Hadoop file system. Only my employee data set will keep changing, right? So today, suppose I have 100,000 employees. Tomorrow, the employees keep increasing, right? So my data set will be changed. But if I say the department data set, so I can use a distributed cache. So distributed cache is a way like we can store the data in memory in one directory in Hadoop file system. So we can use it without any change. Like there will be no change. Okay. So map side join, mostly we use a department, we use a data set which can be fit into memory. So that data set, we keep it in the distributed cache, and other data set, which is large data set, which is very large, we use the other set as we load it as parameter to my mapreduce job. Parameter as input parameter to my mapreduce job. So only one input parameter and one output parameter will be there. That is my output file directory. So one output parameter and one input parameter. So one output parameter is directory path, output directory path, where output file will be generated. This is the same use cases we used it before. Only difference is this small data set we are writing in the distributed cache. So I will show you how to use the map side join. Okay. Second type of join is reduce side join. Okay. So reduce side join is both the data set is large. Both data set are near about large. Little bit difference could be there, but both will be near about equal size. Okay. Just one example is like I have a transactions and orders. So orders, like I have a order ID, order name, order value, right? Order ID, order name, order value, right? Order cost. Okay. And each order is associated with the some transaction. Okay. So I have multiple transactions are there. Okay. Transactions are there. So what I'm going to do here, both order and transaction, I will pass as a mapper. Like so far we have not taken the example of multiple mappers. So here is one is a order mapper and one is a transaction mapper, and we will do the join at the reducer side. This order and transaction, we can found total cost of order. Suppose one person has done multiple order. Okay. So order one and order two, like I have this data set, like customer is there. So it's not order, it's the customer. Okay. Suppose one customer has customer ID, customer first name, last name, its age and designation. And I have another data set is there, transaction. So one customer can have multiple order, right? Suppose I'm saying the example is 40001, 002, 003, 004. So here, if you see here, 4001 has done two transactions. The first two transactions done by the first customer, and 4002 has done one transaction, 4003 is one transaction, and 4004 customer doesn't have any transaction. So what will be the total? So this 4567 and 7867 is a total. 89.90, there is no other order, and 98.90, that is only one order. So my total order will be coming the sum of these two values for 4001. For 4002, it will come 89.90, and 4003 98.90, and for 4004 it will be 0. Okay. So here what I'm going to do when I'm going to one customer data is there and one transaction data is there, and I'm doing the join at the reducer side. Okay. So I will show you one by one. Okay. Let's see first reduce side join. Okay. So reduce side join is very simple here. Okay. So I have taken the example from here. Okay. So here I have this same data set I prepared. Okay. This same data set I prepared here. So customer data set is there and transaction data set is there, right? So I have written two mapper class. So far we are doing only one mapper, right? Because we are reading one data set as a mapper, and that mapper we are processing. Okay. But here is two mappers are there. One is a customer mapper, one is a transaction mapper, because both are the input data set here. Customer mapper is a one input data set and transaction mapper is a one input data set. But here is the difference. The customer mapper data set has customer data and transaction mapper has the transaction data. So how can I recognize in my reducer? I'm using some prefix here. So when I'm writing the data, so what information I need it from here? Customer ID I need it, right? Because this customer ID is present here in the transaction detail. So when I'm sending my one mapper customer and one mapper transaction, so at the reducer side, I will find it out this customer ID, how many times is coming here. And then I will make it sum of those order cost amount. Okay. So the logic is first I'm just appending only prefix. Okay, so what I'm passing here in key 0. Part of 0 means the first one, that is customer ID. Second one, what I'm passing here, cust part 1. Like I'm appending some cust and space or hyphen you can give. So I'm appending name. Okay, cust name. Okay, so I know this particular customer ID is customer type of data, right? This is indicating. And the transaction side, what I'm doing here. So transaction side, when I'm just parsing the data, when I'm splitting the data, my data is a comma separated. And same, I have a data is comma separated here also. So I'm getting an array. This is in Java array is there. And Java array, I'm getting a 0. 0 index means first column. Okay. And second one is name. And here in the transaction, I'm taking a second column as a ID key. Second column I'm taking as a key. So what is my second column? Customer ID, because I'm passing here also customer ID and here also I'm passing the customer ID key. So that keys both are same, but how can you recognize this customer ID has customer data and this customer ID has the transaction data? Because of this prefix. So both are the different types of mapper. That is the reason we are adding a transaction as a prefix. And what is a part 3? Amount. So part 3 is a 0, 1, 2, and 3. That is amount. Because I have to sum of the amount. That is the reason I'm using the amount. Okay. So these are the two mapper code. Simply I'm writing a mapper class, map function, and this map function I'm splitting the data, this value. Okay, value.toString. I'm just splitting this record, this value. And then I'm taking the each part, like whatever part I need it, I will write in the context. So same I did here and same I did here. So here I'm adding customer ID, comma, cust and name. Here I'm adding customer ID, comma, transaction and amount. Okay. And what will happen when I will call the reducer? Okay, now see the code of reducer. So here is a map side join reducer, some class name I given, which is extending to the reducer interface. Okay. So this reducer interface is taking all the field of text type, right? Because all are the text here, because it is not a word count. Otherwise it can take text iterable and text iterable. It is all text because everything I'm giving as a text type, because this is also text type, new text. This is also text type. Here also I'm giving new text and this is also text, because here is no calculation thing is there, no count thing we are doing. So that is the reason we are passing it text. Now what I'm going to do here in my reducer, in reduce function. Okay, I'm getting all the data, whether it's a transaction mapper or customer mapper, all data is coming. So first thing is, when I'm iterating this for loop, I'm identifying by split with the space whether it's a transaction type or whether it's a customer type. Correct? So when I'm just splitting with the space, and I have appended a space here, right? For transaction space and customer space. So what I'm doing here, I'm checking it, this part of 0, because when I'm splitting with the space, so two part will be there. One is a 0 part and one is a 1 part, right? Because it is made of two things. It is made of two things. One is customer, the first part, and transaction first part, and second part is amount or like name, either name or amount. Okay. But in case of transaction, it will be amount. In case of cust, it will be name, right? So what I'm doing here, I'm checking it. If this part of 0 is a transaction, so what I'm doing, total amount, I'm just parsing it, whatever my part 1 is there. In this part 1 is there, right? In the transaction type. So there is a part 1 is an amount. So total is equal to total plus my amount. So my initial amount is 0, 0. So what it will do, first it will take the first transaction and it will do the sum with the second transaction, like this. How many transactions are there? And this count plus plus is incremental value, like initial is a 0 value, and it is incrementing how many transactions are there. So can you see in our data set, 2 transactions are there in our data set for customer 1, for customer 1, for customer 1, 4001, two transactions are there. So count will be for 4001 is 2, for 4002 is 1, and 40003 is 1, and 4004 is 0 transaction. Okay. So what it will be doing here, it is doing the count plus plus and total. Else if I'm doing, if my part 0 is a customer type, right, wherever the data is coming customer, I will take it its name. So name part I will take it, that is a part 1. And here I'm preparing one string where I'm displaying it, the customer, I'm displaying it, how many total number of transaction and total amount. And I'm writing in the context with the key is a name, whatever name I got it here, and total detail about the transactions, number of transactions and total amount. Okay. So this thing is clear. So here is join is happening at the reducer side. Both the mappers are coming here and identifying the which mapper is it is. Then we are accordingly we are doing the calculations, right? So in case of transaction, we have to do calculation. In case of customer, we have to get the name. So name thing we are writing into the key, and the amount and total number of transaction we are writing into the value part. Okay. Okay. This program is clear. So this data set is two data sets are there, customer data set and transaction data set. Okay. And customer ID is a primary key and foreign key. So here is customer ID is there. So here is no primary key concept and foreign key concept in mapreduce, but it is doing the join in the file. It is doing the join in the file. Generally SQL doing the join on the table, and mapreduce is doing the join on the file. But one similarity is there. Here is a one common column is there, which is a joining column. Okay. So how I have written the program, I have written a one single class where I have a two mapper. So reduce side join is my main class, where is a driver is there. Here is a driver. And here I have written two mapper classes. One is a customer mapper, one is a reducer transaction mapper. The only thing we have to remember here when I'm writing as a key, so this should be customer ID, and here also customer ID. Okay, because for the same customer, how many transactions we want, otherwise we can't match it, right? So in the transaction data set, the customer ID is how many times is coming, different if same customer is coming how many times in the transactions. So we can get it by this customer ID matching once we match the customer ID. So here is my logic in the reducer class. I'm splitting the data because here and here everywhere the space is the separator. Here is a space separator, but in mappers we have comma separated. Okay. So here I'm just creating I'm getting the value. So here I'm just getting the value is from the mapper, different mappers I'm getting the value. Okay. So what I'm doing here, I'm just checking it whether it's a transaction or whether it's a customer, and accordingly we are doing. And the driver, I'm creating a job object. I'm setting the mapper class, reducer class. Okay. So reducer class is there and two mapper class is there. So how to add, because last time we added map directly mapper class, but now the two mappers are there. So there is a multiple input format type is there. Then we can add two mapper class here. If you can see here, customer mapper and transaction mapper, and both are the text type. Like text input format means text txt file. Okay. So this all data is a text file. And this code is basically automatically deleting my output directory. So you remember, right, whenever I run the program, so I get the error, right? Output directory already exists. So this code will detect it. What is my output path is there. It will delete it first. Before creating a same path, it will delete the directory and then you will create a new directory. So this program will do itself. So this code, you can put it in any code, like our previous code is there. I can put this code in this word count job. Okay. So here I was not doing this delete thing. So I can put it here. So now what is this one? Input format, right? So I have to copy this. This is set output path. Okay, set output path is this one. File output path. And I have to, okay, this is input path. This is output path. I have to delete a directory. So what is this output path is coming? So here, this output path is my output directory path. Okay. So my output directory path is this one. So one more parameter I created output path and I set it here. It is giving error. So site join. Okay, this output path dot get file system mapreduce. So here is this output path I created. There I'm doing this. So this one, as many as number of times this program I run, now it will not give the error. Okay, so I don't need to delete my. This is my mapreduce DC word count job, right? So my output directory is output 2. Okay. So output 2 directory is didn't give any error, right? As many as number of times I run, it will not give me the error. So if I didn't put that code, these 2 lines, it will give the error. If I comment it, these 3 lines. Okay, now I run. So I will get the error. Output directory already exists. Okay. So output directory is already exists. So this directory is not deleted automatically. Okay. Okay. So this one is a simple word count. Anywhere, like any program, you can write this one. This code is automatically detect your output directory and then it will delete it. Okay. So reduce site join. So reduce site join. So this one, I'm running the program. So here, this is a reduce site join. Site join parameter. Okay. Let's see how many parameters I'm giving. Okay. So no parameter is there. So this is actually reduce site join is this one. So this reduce site join, this is using the reduce site class, reducer site class, and I'm giving a 2 file. So I told you my file is their customer detail, right? In this directory. This is a 1 input file for first mapper. And this is my second file, transaction detail, that is a second mapper. And the third parameter I'm using is the output 1. So output 1, I don't need to delete because the code is handling this. Okay. Apply. Okay. Now I run this. Okay. So now I go to output 1 directory here. So here we have got one part R file. Okay, so part R file, this part R file, can you see here? So I'm getting a customer name and their total transactions and total cost. So can you see this one, the customer, this one, I think this is the, here, transaction detail. So this 4001, the first customer 4001, this is the first, actually ID I'm not printing. I'm just printing total number of transaction and total amount. So transactions are 2 and amount is like this 45 and 78. So it's 124. Second one is 89.90. So only one transaction is correct. Third one is 98.90. That is also one transaction. And fourth one, the customer 4004. So there is no record here, right? 4004, no record. So it is coming 0 amount, 0 transaction. So this is the example of reduced side join. So this is clear, reduced side join. So reduced side join is basically both the data set is large. So if you see, I just took the example like customers and transactions. Like customer record may less, but it will be near about same. Because some customers may have 2 to 3 transactions and some customer has 1 transaction. But we cannot say customer detail is very less and transaction details is too large. Okay. But we have another example is a map side join. There is a employee and department. So employee data set will be large and department data set will be small. Okay. So this example is clear. This is the second type of join I told, reduced side join, where 2 different types of mapper are going to join in the join into the reducer side. Okay. Because we need to identify which mapper has cost and which mapper is having name. Okay. And we have to match the same customer ID. How many transactions are there? We are doing the sum of those transactions. Okay. Okay. So another example is map side join. Okay. So map side join, I have created here the 2 classes. It's simple than the reduced side join. So only thing is here I'm using distributed cache. Okay. So map side join is having okay. So this map side join having first is a mapper class. Okay. Before mapper, here is a setup function is there. Why we need this setup function here? Because I told you one small data set which can fit into memory. I'm adding into the cache and I'm reading cache here. So distributed cache is a class that get local cache file. How many files are there in the cache? Okay, right now I put it only one file in the cache. Okay, I show you how to put in the distributed cache. So in my Hadoop file system, so this program you can run reduce side join you can run in the cluster also. So what is the way to run the cluster? So you have both the files on the Hadoop file system. So first you have to like this my transaction detail and customer detail I have to copy in Hadoop file system. Okay. So I just make the directory Hadoop fs minus mkdir and I create reduce side join. Here I just copy these are the both are the mapper input file. So I copy it Hadoop fs minus put and first is a customer detail and I'm copying the reduce side join. Okay. Second file is I showed you the local, right? Local I run in the IntelliJ, but this one I'm running in the cluster, same program. Okay. Customer and transaction detail. So both I have copied. So both I have written in the Hadoop file system. Okay. So now next thing is we need to create a jar because without jar we cannot do. So one jar we have to create. So we have a Maven project, this one. So this Maven project has different Java classes. So we should know which driver class we have to execute because this is also main class. This is also main class. Word count job is also main class. So we should know which main class we are going to run. Okay. Because jar is same for all the main class, all the driver class, jar is same. Okay. And we can make it more like a more easy way, like we can create a separate package. Like one package I can create for the map side join, partitioner, word count. Okay. But right now is all the classes are in a one package only. Okay. So when I run this, so first of all, I remove this target because I I want to see my jar is creating or not. Okay, I run this and this one I showed you. Here I have to give the two parameter in the run, clean and package. So this is a mapreduce maven type of configuration we have to create and give the clean package and give the folder. Okay, so this is already everything is set. If you just create a new one, just click on maven, automatically will come a new one, right? So this one come new one. Okay, so it will take it automatically your folder, which folder you are going to create your maven configuration, it will take it that folder. Only thing is you have to put the clean package. But if you write this clean package here, so both will become same or not, right? So it will not allow, because both are same thing, whatever I'm doing. Okay, so if I try to do, it is not allowing because the same name is already there. Okay, so I cancel this. So I have done this and my jar is created in the target. Can I see my jar here in the target? And here is my jar. So I copy this jar. And I keep it. Okay, here is already one jar is there. So I'm overriding it. So my jar is this name, mapreduce word count jar. So in the same folder right now I'm there, mapreduce wc ls. So here I'm there, this mapreduce word count. So this is the latest jar, 1641. So how to run my mapreduce jar command? Hadoop jar name, mapreduce word count jar. Now I have to decide which class. So if I'm going to give my class, so I have to give correctly my class. com.example is my package. And what is my class name of reducer? Word count reducer. This is my main class name. Because package is same for all. So I'm giving my class name. And next thing I have to give two input path. You remember when I run it here locally, so I have provided in my reduce side join here. In this reduce side join, I provided two packages, right? So one is this and one is this. But what is the difference in this one and what I will give in the Hadoop one? What is the difference? Should I copy it the same and run it? Can I pass this parameter there or I have to change it here? What do you say? So this parameter is for my local, right? Because my local path is there. So it will not work. Because right now I'm running the job on Hadoop cluster. So my path should be my Hadoop one. So what is my path? I loaded the file. Reduce site join. This is my directory. Reduce site join slash directly customer detail, right? I copied the same file, customer detail, in my reduce site join folder. This one, reduce site join slash customer detail. That is the one path. Second path is reduce site join slash transaction detail. So just make sure like a spelling should be correct. Details. Okay. So these are the two paths. Now next one is a output path. So these two are input. Generally, if one mapper is there, so one mapper input and output. But here is two mapper and one output. So output I want to create, reduce site join is already there. I will create a new directory here, output one. This should not be present. Otherwise your code will not work. But here in my code, already I handled it, right? Even if it is creating, if I'm running multiple time also, it will work. So class not found is coming. So I have given the wrong class name. Com.example. Okay, this is not com.example. This is org.example. So my package name is wrong. That is the reason it is not able to find the class. So this is org package. Okay, so now it's giving error. No such method. Word count reducer dot main. Word count reducer. Oh, this is only reducer class. Okay. I have to give driver class. So here is reducer is separate class. Mapper is a separate class. Okay, map function is there. I think. Oh, okay. This is different word count reducer class. This is the reduce side join class. This is a simple word count one. Actually, three classes were there. Word count job is a driver, word count mapper is a mapper, and word count reducer. So these three classes, that is the reason we should use the package. Because if we are keeping it in separate package, we can easily identify which classes are related to which package. So these three classes are the simple word count. Partitioner demo is a partitioner related main class. Reduce side join is a single class that is also main class. And here in the map side join, driver class is a driver and mapper class is a mapper, because there is no need of reducer. So this class I have to use because here is all classes are there, inner classes, right? Mapper and so reduce side join is a our main class. That is the reason it is not able to find the main function. Okay. So this reduce side join is my class. Okay. And output one, even this folder is created, but it will automatically handle. So now my job is running. This is my mapreduce job. Okay. So map is 0%, reduce is 0%, map is 100%. Okay. So what is the reason why reduce is not started here? Like here is showing map is 0, reduce is 0, map is 100, reduce is 0 still. Why reduce is not started? Why they haven't started reducer here? Why it is started when the mapper is 100, then reducer is started and then it is completed? The reason is any program, there is a contract is there, like once mapper is completed and then reducer will start. Okay, it cannot be run mapper and reducer parallelly. Mapper can run itself parallelly, right? Because mapper has multiple mapper machines are there, those are running parallelly. But when it comes to reducer, so well, when all mappers are done, even the last mapper also left, once that one will be completed, then only your reducer will start. Otherwise, what will happen? Suppose you haven't wait for all the mappers done. So what can be problem? Your output will not come correct, right? Because I think if you started the reducer and your final mapper, which is not completed, then it will be give your result wrong, right? So we have to wait complete all mapper. Okay. So mapper should be complete 100%, then only we can start reducer. That is the reason reduce is 0% till all mappers done. Once it is completed 100 and then it will be 100. Okay. So here is the file is created. Okay. So now I checked in my Hadoop directory. So Hadoop fs minus ls reduce side join, and my directory is output one. Output one. So here in this directory, okay, first I check what is. Oh, I forgot to reduce side join slash output one. So in this directory, I created one part R file. So I'm now checking this file out. Part R hyphen 5 zeros, and I have to use cat command because I want to see the content. So see, this is the same output. It just like I'm showing you the output because of like it's running on the Hadoop. Okay. So when generally the right approach is this one only, like final the job you will be running on the cluster. Okay. Same like a Spark program also we can run in editor as well as we can run in the cluster. But generally editor one is just for testing and cluster is running actual job running in the cluster. Okay. Okay. So another one program is there, that is map side join. So map side join, we are using a distributed cache. Okay. So here is in map side join, the driver class is there. Okay. So driver class is this one, driver map side join distributed cache. So here, if you see, we are adding a cache file. So distributed cache dot add cache file. my department.txt I'm adding in the Hadoop path. So this is a map site join, some folder name distributed cache, and my file name is a department.txt. Okay. So here I'm just adding this distributed cache.add cache file. So whatever file we have to add in the distributed cache so that it can be provided at runtime. Okay. So I don't need to load it manually through the parameter. Okay. Other one is my other files is there, right? The other parameter is coming args0. That is my employee.txt file. Okay. And this args1 is my output directory. So this all code you know, and right, this map site join, there is no reducer. I will make it my reduce task 0. I will not perform any reducer. Okay. So my output directly coming from the mapper. Okay. And that is the reason my output file name will be map-m part-m-0000. Okay. Now we look at the mapper file for this one. So this one, I have a one function is a setup function is there. So whatever files I added in the cache, I am reading it here, distributed cache and get local cache file. So whatever file is there, I'm just matching it, because it could be a scenario like your distributed cache may have different small file for different program. So distributed cache could be a one directory which can have multiple file. So I'm matching it with my program file, department.txt. So wherever it matching it, I will load the data into some hash map. Okay, so this function is down here. I'm reading a file. This is a Java logic. This is a purely Java logic, which is I'm reading a file. And department.txt is just 2 columns file is there. So department.txt is like this: D001 marketing, D002 finance, and D003 human resource. Like this, I have a tab separated data is there. So I'm just separating this data by tab //tab, and I'm creating a array. And this array having the two values, one is a 0 and one is a 1 index. The 0 index is a department ID and 1 is department name. So in this hash map, this is a Java class hash map. This is a hash map type, hash map key and value. Both are string type. Department ID is a string and department name also is string. So I'm adding this key value pair in my hash map. So department ID with department name. So this map has two things, key and value. Okay. So when I will give this hash map to key, I will get the value. So what I'm doing in the map function? So map function, first of all, I'm separating my employee data. So my employee data is also separated by tab. Okay. If you look at your employee data. Okay. So this is employee data. Employee ID is the first column. Employee date is there, joining date. Date of birth is there. This is date of birth. Then first name is a separate column. Last name is a separate column. Hire date is another column. I think here is okay. Date of birth and male, female is coming. First name, last name, and gender is coming. Okay. So this is one column, second column, third column, fourth column, fifth column, and sixth column is my hire date, and seventh column is a department number. So this department number is like a joining column. Here I will not say primary key, foreign key, because this is a text file, but here is a joining common column is there. That is a department ID. Okay. So this seventh. So if I calculate here from the 0, so 0 index, 0, 1, 2, 3, 4, 5, 6. Sixth column I'm giving as a department number. So how to get the value of department name? By passing the department ID. So here I'm calculating, I'm just getting it, my hash map dot get, I'm passing the sixth column, that is my department ID, and get the department name. Okay. And if I'm not finding, suppose like my input file, employee file has some department ID is wrong. So definitely I will not find any value. So in that case, I'm giving not found. Okay. So this department name. So what I'm doing here in mapper, I'm creating a one single string. I'm creating a one single string as a value, and key will be in context. I'm writing this key and value. So key, I'm writing my employee ID. So employee ID, I'm adding a key, and value, I'm adding the concatenation of the data by tab. So first one is employee ID, name, employee ID, and second one is a date of birth. Then first name, last name, and gender. Gender is there, and next is gender column, and then date of joining, hire date, and department number. So gender, department, okay, gender, department. So 0, 1, 2, 3, 4, 5, 6, and 7th is the last is a department name. So my output should look like here, like this. So 0, 1, 2, 3, 4, 5 is the gender, 6, 7, 8. 7, 8. So my 0 to 7 column should come 0 to 0 to 7 and 8, 0, 1, 2, 3, 4, 5, 6, 7, and 8th column. Okay. So I think here I'm giving 0, 1, 2, 3, 4, 5, 6. So one more I should add it for 7. I make it 7. Okay. So for this program, if I want to run this program, so what I need to do, I have to create again jar. So I have to create a jar, and my project is this one, mapreduce WC. So I run this one. So I create a jar. And this jar, I will get it in the target. So here is this jar. We copy this jar. Here is, this is the main. Here I'm overwriting this jar. Okay. Now the question comes like I have to set this distributed cache directory. Okay. And one file is employee.tsv, right? So what I did, I'm creating a Hadoop fs minus mkdir. If you map site join, I already created folder. So I'm creating map site join 1 and Hadoop fs minus 4. Entire directory I can copy also. dc slash map site join 1. So it will copy complete directory, means whatever file inside this, that will go also in this dc has a department.txt. Okay, so I prepare the file in my local and I'm copying it. And next file I'm copying it, that is employee file, employee underscore tsp. Okay, this is the name of the file, and I will do this. So it will copy it directly. Now my jar is here, so I run my Hadoop jar command. Hadoop jar name is same mapreduce. Okay, org example. And now I have to take it my driver class. So my driver class is this is my driver. So driver, this one. So this is the main class should be driver. I copy it, and I have to provide my input file only, because distributed cache it will get it directly. I have to provide the input file. So map site join 1 slash employee tsp. the employee underscore TSP, and one more output directory I have to give, map site join 1 slash output 1. I can give because this is a new directory, so it will create a is array index out of bound means like some number of columns, we have to just match it. Here is tab separated, so we are adding 0 and 1. Okay, this is a department 1, and this is a /t I'm giving, and I'm getting how many column total. So here I'm giving 6 1. Okay, so my department is a 7 1 field. Right, this is my department, right? Last field in my input. Last field is an input. Last field is an input. This is the 0 1 0 1 2 3 4 5 6. What is missing? 6 column. So in output is coming 8 columns. What is the column? Oh, this and this 2 times. Date is coming. This is same. So here is one. 2 times he added 1 1, then 2 3 4 5 6. Okay, as it is, we copy it. 1 1 means 2 times it is giving the 0 is okay. 0 it is not appending because 0 is already added in the key. So 1 1. Okay, 2 times 2 3 4 5 6. Okay, let's say. Output name. Okay, I will check it, but output will come. This kind of output will come. So you will get the tab separated data because you are adding the tab, so you can get all department ID with department name. So your output is coming directly from the mapper. So this is part M file is creating. Okay. So your output file is created as a part M, and then this is coming. Okay, so this link I will send it. Okay, in the code, whatever I'm writing here, the code in this text file. So this is all example. So map site example is map site join. So this example is okay. So this example is a map site join, and I will give this project all project in zip, so you can, but you need to change in the reduce site join. Okay, so reduce site join, you have to change it. Okay, this is the example of it. So whatever classes I will give it, I will give you this complete project as a zip. You extract it and there is an option file open. So file open, you go to the location where this extracted project, mapreduce word count WC, you can get in your workspace. And once you get in your workspace, just do the changes of in my, like in any hard-coded path, or like you have to create this. Like, okay, if it is coming directly in your one, so you have to change your username and those things you have to change. This path you have to change. Okay, and you have to create the files, and files I will send also. Okay, so these files are there in this folder. I will give the 2 files are for this customer and transaction. These are for reduce side join, and this file is for, and DC, this is distributed cache. This one is for map side join. Okay, so I will give this one, and jar you will create when you do the Maven build. The jar will be created. Okay. Okay, I'll share this one. Okay, and Monday I'll start the Hive. Okay. So if you go through the Hive concept, SQL queries concept, so that will be good. Okay. Any question anyone has? Okay. So Jay, have you done the installation? That last time you said some issue.
Yeah, I'm done with it.
Yeah, I'm done with.
Okay, okay. And Hadoop installation?
Yeah, I'm done.
Yeah, I'm done.
Okay, okay. Hadoop command you can run, and MapReduce program also you can run by this IntelliJ editor,
Oh yeah,
right?
so I haven't started that.
Okay,
But actually,
I'll send this code so that first you run it directly, whatever I'm sending,
Okay.
and then you want to write small is just this MapReduce word count program. Do practice just small this one. These
Yeah,
3
I just
classes code.
one question, because
It's a
actually
lengthy code. It's a lengthy
yeah, I know
code. Just
Python, but this language I don't know.
I will
point
share
to
the Python also. I will show the Python logic also. So Python logic is also the same, but just Python, just few lines of code. The same thing we can write in Python, just hardly 4 lines of mapper and 5 lines of reducer and 3 lines of driver. Like it's just very small code. Okay. So there is a I'll show the Python one, but Python one cannot be run in the distributed manner. It's a sequential manner it runs. Okay.
Yeah,
So just for testing purpose, Python MapReduce you can run, but actual cluster, right? Like
but
you
mostly
want to
they
write a
won't
custom.
ask this program. I mean, is it significant to learn this? Like really, because
See, my purpose is to, I'm not saying to write a MapReduce Java program, but
Okay,
for understanding
understand.
point of view, if you
Yeah.
know this concept like partitioner, combiner, reducer,
Okay.
so you can, because some interviewer, they straightforward, they ask these basic concepts. And if you tell them theoretically as well, right? Like how did you implement it? You write a mapper class, you write in a reducer class, there is a map function, reducer class, a reduce function. So that's enough, right? And sometimes they say, just can you write two lines of like mapper function code? So just remember it, this part, like this while tokenizer one. This can be reduced. Actually, here is a counter is coming. This will not be needed. This part. So it's hardly 3 lines of code. If I say, if you don't write just map function, right, and then you write this. Okay. I will provide the very shorter code, like for writing only map, reduce, and simple driver is having this 5 lines. That's it.
Okay.
So you don't need to write a package or everything, because everyone can understand, right? Because nobody can remember the packages. So they ask you simple, just driver logic, mapper logic. So mapper logic is like you are splitting the word by space, and then writing each word as a 1 count. And reducer logic, you are defining some integer, some variable. Okay, and then you are aggregating the value, like for each value of iterable type list.
Okay.
Okay, I'll give like very short code, which can for practice purpose you can do on Notepad. You can practice. Okay.
Yeah, that will help. Thank you.
Okay, and I will share this complete project, so you can import it, and then you can see that only in this form.xml only one jar we are using here, Hadoop client. So just remember it. Okay.
Okay.
Okay. Yeah. Thanks everyone.
Yeah. Thank you.